Welcome back. In the previous lecture, we introduced a new data structure, singly linked lists, and we saw that it offers some advantages and some disadvantages over traditional lists. What were the advantages? Insertion, deletion, appending are fast. Actually, appending wasn't fast because we had to get to the end of the list. So insertion at the front of the list and deletion were fast. But random access, accessing an ith element of the list was slow. Okay, so what we're going to do now is we're going to introduce a variant of the singly linked list, and that is the circular doubly linked list with Sentinel. Okay, so a couple of things. There's a lot of words in here, but conceptually you can see that this is a lot like a linked list. There's a little bit more activity going on because of the Sentinel, the circularity, and the doubly linked list. But the same basic idea, you have a bunch of data, Maine, Idaho, Utah, strings. They are attached to a node. The node is a little more complex right now, and they have this loose affiliation. But you can see that this data structure, unlike a singly linked list, has a couple of features. One is there's a link going in both directions. So that is, there's a next pointer that gives me who is next in the list, and there is a previous pointer that tells me who is pointing to me. Why do we do this? Well, it just gives you a little more flexibility. There's no fundamental reason why you should only be able to walk through a list in one direction. Being able to go back and forth is often convenient. So we simply are going to hold on to two pointers now that tell me who is pointing to me and to whom am I pointing. So that's what we mean by a doubly linked list. Sentinel simply means, and you can have this with a singly linked list, is that there's a special node at the front of the list with none in the data or something that signifies that it is not one of the data fields stored in the list. The sentinels are going to be nice because of the circularity, which you'll see in a little bit. But basically all it means is that there is a special node in the list, it doesn't store any data, and it signifies the start of the list, hence the term sentinel. So now we've seen double linked list with the sentinel, and now just the circularity, which is just the obvious thing, which is that when you get to the end of the list, the next pointer points to the front of the list, which in our case is a sentinel. And if there was no sentinel, you can have a circular doubly linked list without a sentinel. Then you would just point to main. And the previous link on the first element of the list points to the last element of the list. So it's a circular doubly linked list with a sentinel. So right out of the gate, you can see one advantage of the circularity, which is now if I want to append to the list, I don't have to go all the way down the list. I can simply start at the first one, go to the last element, and then tack on a new element with insert. So this circularity is going to deal with that weird thing where to get to the end of the list, you had to do big O and operations. All right, so let's see how we implement this. So we're going to do this time with two classes instead of one. I'm going to have one class which is a node. That's just storing the data, the next and the previous pointers. And then I'm going to have a Sentinel DLL, so Sentinel doubly linked list, and that's going to be responsible for wiring up these nodes. So this is a little bit different than how we did it before, only because now I want to be able to separate these classes and have this class use this class to build the list. So let's start with the node class. Well, this is about what you expect. It's very similar to the singly linked list. I have every node is simply an object with three fields in it: the data, the next pointer, and the previous pointer. So constructor for the node, self of course is the address of the object, and you pass it in a data. And for now, we're going to assume that you don't pass it in the next and the previous. Wiring up a list will be the responsibility of the Sentinel DLL. So I'm simply going to assign three data fields, data, next, and previous, to the object. The data, of course, is the data you passed in, and then I'm going to just wire it up to have a none for next and none for previous. So this is what the object will look like of a single node after you call the constructor from the node class. All right, so that's pretty straightforward. And so let's now build the constructor for the Sentinel DLL. Okay, so with the Sentinel, remember a Sentinel is a doubly linked list. The Sentinel DLL simply has a special node at the front of the list that has none in the data field. Okay. So to initialize a doubly linked list, what does it mean? With a Sentinel, it just create an empty node and wire your next to be yourself and your previous to be yourself, and that's the sentinel. All right, let's just do that. That should be pretty straightforward because we already have the constructor for the node. So here's my constructor for the sentinel DLL. This object, the whole list, will have one data structure, one data element, which is the sentinel. The sentinel itself is going to be, of course it's a node. So we're going to call the node constructor, that's this guy right here, with none in the data field. What will that return? It will return to me a node with none in the data field, none in the next field, and none in the previous field. And what I want to do, because I want this to not look like there's nothing here, I want to make it look like there's a single element pointing to itself, I'm simply going to wire it up so the next field points to myself and the previous field points to myself. And I can do that with 2 lines of code. So the object dot sentinel, what's the sentinel? Just a node, dot next. So notice I'm tapping in to the next field of the node is equal to self.sentinel. So my next field is going to be a pointer to a node. And if I simply point it to myself, which is itself a node, I create this circular part right here. And then for the previous, I do the same thing. So notice that the reason I did this is because this is a circular doubly linked list, and the circularity says that the last element in the list should point to the first element, and the first element should point to the last element. Well, if you only have one element of the list, you have to simply point to yourself. Okay, good. 2 simple classes with a single method function, which is the constructor for the node, constructor for the sentinel. And again, I've separated these things out just for sort of clarity. There's going to be a bunch of node functions down the line and a bunch of sentinel and a bunch of DLL functions down the line. These obviously operate on the list, whereas these will operate on individual nodes. All right. So let's write a simple function, and then in the subsequent sections of this lecture, we're going to do some more functions on the doubly linked list with a sentinel. So let's write a function just to make sure we understand the constructors and the underlying data structure called first node. So this will take as input, it's a member function of the DLL, and it's going to tell us, it's going to return the first node in the list. Okay? And if the list is empty, it returns none. All right. So first of all, the question you want to ask yourself is, what does it mean for the list to be empty? Well, it means that the only thing we have is a sentinel, which means that the next pointer points to myself and the previous points to myself. So that's how we know we have an empty list, because that's what the constructor did. It created an empty list. So we're going to ask if self, that's the object of the DLL, dot sentinel, that's the single data associated with this object, dot next, so sentinel is a node, we reach into next, is equal to myself, well then I know I'm empty. And notice I don't have to check the previous, because once I've determined that my next pointer is myself, well then the previous must by definition also be myself. So if that's true, I'm going to return none. And I'm going to return none is because there is no first node. This is not a node in the sense of it stores data, it's the sentinel. It is the gatekeeper to the rest of the list. And that if that is not true, well then I'm simply going to return the first node. So what's the first node? It's self.sentinel.next. So the sentinel points to the first element in the list. That must be the first node by definition, and I simply return that. Okay? So this is just a little example of how we're going to call this. D is equal to, I call the constructor for the sentinel DLL object, and then I just say D, that's the entire list, dot first node, that's that member function right there, and I get the first node, which will either be none, if the list is empty, only has a sentinel, and it'll be the first node. Okay? So that was just a good exercise to make sure you see there's several levels of indirection here. We're going from the object to the sentinel to the elements of that sentinel, which itself is a node. Okay, so make sure you understand those 2 objects and how they interplay with each other, because what we're going to do next is start building on this and writing more DLL functions like insert, append, delete, and find, which are the natural things that we want to do with a list. So when we come back, we'll pick it up right there.